Open up the champagne, pop. It's my house, come on, turn it up. Hear a knock on the.
Hi, I'm Sebastian.
Hi, I'm Hugh. And today we're going to teach sigfigs.
Yes.
Alright, so let's get started. Okay, so the first thing I'm going to be teaching is that all non-zero numbers count as significant figures. So for example, if you have the number 163, then you have 3 sigfigs. Even if you have zeros at the end, wait, that's different.
It's a different rule.
So if you have 16,388, that counts as 5 sigfigs.
残酷な天使のように少年よ神話になれ
When dealing with sigfigs,
Sometimes you'll come across zeros at the end of your number.
and those would count if they're behind the decimal, like this. How many sigfigs are there, Kiki?
If I look closely, it appears that there are 7 sigfigs.
Why? I only see 2 numbers and 5 zeros.
Well, David, this little decimal block here, that allows all of these zeros to count. Which means this number is significant.
What if I had something like this? There's still 5 zeros.
Yeah, David, but there's no decimal to back up that all of these zeros are significant. So now, it's only 7,200,000. Which means there are only 2
7 million.
sigfigs.
7 million.
7,200,000. But there are only, but there are only 2 numbers. That count.
Okay, so the next one I'm going to be talking about is zeros before a number. So, for example, if you have 00056, you only have 2 significant figures, and the reason why is because these zeros are placeholders. So even if it's decimals, 0.57, you only have 2 sigfigs. No matter no matter how many zeros you have.
That's like a gajillion zeros.
I know, Davo, but they only have 2 sigfigs because of the fact that zeros are placeholders.
Ba 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 na 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 ba 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 na na ba 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 na 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 ba 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 na naとかりのポタトリカにマロマニカのキカババ
So we've talked about ending and beginning zeros. But what about middle zeros? I'm here to teach you that middle zeros always count no matter what the situation is. So let's say our number is 14 million.
Go.
600. Oh, what is that? That's a middle zero. That still counts. Or let's just say our number is, I don't know.
How many sigfig is that?
Well, let's count. 1, 2, 3. Oh. This, how many? 5 sigfigs. 5 sigfigs. Because remember, ending zeros don't count. Let's say, I don't know, our number is. Look at all those zeros. Do they count? They count. These guys count.
What do they count?
How many sigfigs? When measuring an item such as this cranberry Sprite can, you were unable to detect its actual length because of how undetailed our ruler is. So we're just gonna have to estimate how many sig figs this is. So as we see here, this is about 4.7 inches long, but that doesn't really, because it's false, we're gonna have to assume
That there's more numbers.
that there are more numbers. So it'll give us 3 sig figs. So by looking at this, we can guess, I don't know, maybe 4.78 inches long, which gives us 3 sig figs. So with rulers, if you can only see up to 2 sig figs, no matter what you say and what you write the data down on and what you calculate, you have to add an extra sig fig.
Alright, so when you're multiplying sig figs, so for example, you get 1.1 times 2. You look at the smaller sig fig number. So for example, instead of using 2 as a sig fig, use 1. You have to use a smaller one. So when you multiply this, you'll get 2.2. But when you write down your answer, you have to write it down as a 2.
I wanna be the very best, like no one ever was. To catch them is my real.
Thank you, Mr. V.
Arigato.
Gracias.